If you have ever planned a beach trip around the surf or a boat launch, you have likely noticed that the ocean does not run on a standard human clock. You check the tide chart, and it tells you high tide will hit right at 9 a.m. But if you show up at 9 a.m. the very next day, the deep water is missing. High tide has pushed back to 9:50 a.m. Every 24 hours, the ocean falls almost exactly 50 minutes behind schedule. To find the source of this delay, we have to stop looking at the water. We need to do what ancient sailors did and look at the sky. If you watch the moon rise over the horizon on a Monday and then wait for it on Tuesday, it will arrive late. Just like the tide, it rises roughly 50 minutes later every single night. The rhythm of the ocean and the schedule of the moon are perfectly synced. A celestial clock, invisible from the shore, is controlling the sea. Earth spins every 24 hours, while the moon orbits every 27 days. Because both move simultaneously, a 24-hour rotation leaves you facing empty space where the moon used to be. Earth must spin an extra 50 minutes to realign. Every day, the Earth runs this cosmic race, and every day, this 50-minute astronomical catch-up is the reason our schedules for moonrise and tides shift forward. To move an ocean from 238,000 miles away, gravity acts as an invisible tether. The moon's pull reaches down, physically lifting the water toward it. Modeling the Earth covered entirely in water reveals a primary tidal bulge forming on the side facing the moon. Gravity also produces a second identical bulge on the exact opposite side. This second bulge is caused by inertia. As the moon pulls the solid Earth, water on the far side resists and is left behind. The bulges stay locked with the moon, while your beach rotates through both every day. Because the moon moves ahead daily, dragging its bulges with it, the Earth's rotation through these shifting mounds dictates the delayed rhythm of the sea. While the moon is the primary driver, the sun also exerts a massive pull. It is vastly larger, but much further away. This introduces the inverse square law principle. A physical force, like gravity, decreases in strength in proportion to the square of the distance from its source. Because the sun is so distant, the tiny, close moon pulls on our water more than twice as hard as the massive sun. During a full or new moon, the sun, Earth, and moon align. Their forces team up, stretching water into extreme spring tides. A week later, at a 90-degree angle, their forces fight, causing bulges to shrink into weak neap tides. This precise geometric alignment of these three celestial bodies determines the extreme highs and lows of the ocean surface. The data on a tide app is more than just a local schedule. It is a direct reading of the solar system. We can see the connection here. The 50-minute daily shift and the changing height of the peaks mirror the moon's orbit and its phases in real time. Watching the ocean rise and fall is a way to witness the gravity of distant bodies actively shaping our world.